One nice feature of Servant is the ability to define safe links. Links that target endpoints in your API without fear of misspellings or targeting an endpoint that doesn't really exist or things like that. And that feature is provided in module Servant links. So I'm going to give a small example of how it works. I have this example API which uses root records to structure the different endpoints. And in particular, I have this main record here, which has like a simple endpoint here, an endpoint that has a dynamic segment here. So that part, if we were creating a server for this API, this part will be received as a parameter. And then also it has another root record nested in this path. And in its turn, the nested record has like an endpoint and another endpoint that has a capture as well. So, what I would like to have is some kind of data structure that contains all the endpoints that are possible in this API. And for that, I'm going to use a function in Servant links called all links. And the way it works is that you pass it like a proxy with the type of your API, and it returns you like some data structure of links. And links in this module are represented by this opaque type, which then you can convert, for example, to URLs or to other things. Okay. So let's do it. I'm going to declare a roots value, and I'm going to use a link. I'm going to pass a proxy with the type of my API, this one. Okay, and I'm going to accept the suggested type signature. And what is this type? So uh, the collection of roots is the record foo parameterized by this type. And if you remember from a previous video in Servant, root records are parameterized by a mode, a type, which depending on the mode, the fields are interpreted in a way or another. And this mode parameter here basically says interpret the fields of the record as link builders, so to speak. So I'm going to inspect this record that contains all the roots. First, let's check the type of the first endpoint, which has simply type link, and we can try to print it. It's well, it's better to print it uh, as a URL, and we see that it's simply the path foo. How about this other endpoint which has a dynamic segment? Okay, this endpoint has, instead of simply being a link, it has type int to link. So why? Because we have a capture, a dynamic segment. We really need to provide a value for this segment in order to have the full URL. So let's do it. and we convert it to a URL. And so we have this. Okay, let's now see how the nested endpoints are rendered. Let's inspect the type of the nested field. So the type of the nested field is the bar record, parameterized as before in foo with the ASLink mode. So we can go into the record and let's see the type of bar endpoint. It's a link, so it's printed. So as expected, like we go here, we enter here, then we go into here and we render this path segment. And from this endpoint with a capture, we expect it to be similar. Again, because of the capture, we have a function. Mhm. And here we have the URL. Notice an important thing. The links that are contained in bar are in the context of foo, like they don't begin by bar or bar captures. They begin with nested, like the initial part comes from the outer record. Okay, so far we are generating the links and then converting them to URLs. But suppose we wanted to actually get URLs from the beginning, like without having to convert them after creating the links. How can we do that? Well, Serval Links provides a generalized version of all links, which is very similar, but it accepts a function, a transformation that will be applied to the link when it's eventually produced. So what we can do is let's define an alternative uh, record of roots. So I'm going to simply pass the function to convert a link to a URL here, and then I'm simply going to pass the proxy again. And okay, there I accept the signature, and notice that the type is very similar. It's also a record of roots, a record of links, but now the parameter of a link is URI because that's the type that we will ultimately, that the link builders will ultimately produce. So let's try. See, we see that now the link has type URI, and we can print it, and as expected, it will be full, and the same with the others. You may ask yourself, why is this useful? Like this generalized version of all links? Because before we were simply applying the transformations that we needed after obtaining the link. But I think this generalized version is useful because in your code, the point at which you create the record of URLs may not be the same point in which you extract the links. So when you construct a record of URLs, you may have more information available to transform the link as you wish. For example, imagine like that we instead of relative URLs that the relative URLs that we are getting so far, we wanted to generate absolute URLs. Like I have here a base URL, and I want to generate a record of links that where all the links are prepended by this base URL. And we can do it with the generalized version of all links, like this. Mm, If two, okay. So relative to is a function from network queuing that basically prepends an absolute a base URL to a relative URL. And let's check that it works. Oh, and it does. Like every time we generate a link, uh, it's already generated with the base URL prepended. So that's all. Bye.